Okay, let's review functions just a little bit. Let's remember what this means. F of 0, that means that my input is 0. Now this function, what it says is I'm going to take my input, -2 times whatever my input is plus 5, right? Well, it just so happens this one we have a specific input, and it is 0. -2 times 0 is 0, plus 5 is 5. Now let's look at the next one. -2 is my input. The rule still says -2 times my input plus 5. -2 times -2 is 4, plus 5 gives me 9. Now, this looks a little bit different. Same thing though. It says that my input, -2 times my input plus 5. Well, really, that's just -2 times A plus 5. This, same thing. -2 times my input plus 5. Just happens this time my input's a little bit bigger. It's A plus 1. Now we're just going to make it prettier, distribute, and combine your like terms. That's it. What you have just done is what is called a composition of functions. You combined this function, inserted it into another one, and made a new one. Composition of functions. It's combining more than one function to make a new one. And how it really works is you've got one on the outside, and you're plugging in another function. Now, in this case, we actually wrote the function out. Here, we're just doing it generically. You have a function inside of a function. This really means f of g of x. Now, sometimes you might see that as f of g of x. That is not fog, that's just a little o. Okay, so what this really says is to take your input, apply g, so we apply the rule of g first, then apply f. Easiest way to really look at this is using one of those function machines that we talked about before. So first, let's identify our functions. We've got one named f, and we'll have another one over here named G. Okay. If I were needing to find f of G, let's say of -2, what that means is I'm going to take this input, apply the rule of G first. That means to take our input and add 1 to it, and then apply the rule of f at the end. So I'm going to use the function machine here. Here's the input. The first box it goes through is the rule G. G of x says to take whatever the input is and add 1. And I'm going to get some kind of output. Now, once we go through that machine, we're going to go through f next. Now, f says to take -2 times whatever the input is and add 5 at the end. So let's see what we end up with. When I go through this machine, this one says to take the input and add 1 to it. Well, that one's easy. That gives me -1. Now the output that I just got here becomes the input for the next one. So f's rule says -2 times my input, which is now -1, and then I'm going to add 5 to that. -2 times -1 is 2, plus 5 is 7. Let's see what happens when we reverse the direction. What if I have g of f of x, or f of plug in negative 2 this time. Same thing. Same input. We're going to plug in negative 2. But this time, the first box I go to, or the first procedure I'm told to follow, is going to be f of x this time. Then since g is on the outside, that's going to be the last wrapper I have to go through to get out. Okay? So here this says negative 2 times my input plus 5. That's 4 plus 5 is 9. The rule of G says to take the input and add 1. Now remember, we're using the new input, which was the output. Kind of like going through lenses or going through shields or screens. You have to go through one to get to the other one. Let me put down one more. And alright, so this time we're using just a generic input of x. But it's still pretty easy. We're going to take x and apply the first function. And this one says I'm going to take it and apply g of x. Now g of x was that rule that said I'm going to take the input and add 1 to it. Well, gosh, that's easy. We just get x plus 1 out. Now f of x will be the next one we go through. F of x says I'm going to take negative 2 times that input plus 5. Now remember, now this is our whole input is the x plus 1. So negative 2 times x plus 1 plus 5. And we can make that a little bit prettier. It's going to be negative 2x minus 2 plus 5. Or negative 2x plus 3. Now I'm going to skip around a little bit on the discovery worksheet just to cover some really important things. So I'm going to go to the second page of it if you're following along. And we're going to do the same type of thing, but now we've got this f of x equals 3x squared plus 2 is our function. So f of 3. Now this goes back to the easier ones. Remember, that just means to plug in 3 as your input. So 3 of 3 squared plus 2 gives you 3 times 9 plus 2, or 29. F of a means to plug in a for x. It's going to be 3a squared plus 2. The reason I'm choosing to do these problems is really because of 6 and 8. I've noticed that people are having trouble remembering these rules, so I really wanted to go over this with you. Now this time we're plugging in all of a plus b. So that's going to be 3 times a plus b squared, then add 2. Some people are forgetting what it means to square something. So let's kind of come off to the side and work this one out. I'm going to bring it up here. So when we square something, that means to multiply it by itself. So that's going to be a plus b times a plus b. And remember, this is just the distributive property to multiply these two together. You'll have a times a, which is a squared, a times b. Here's another one, b times a, but I like to write them in alphabetical order, so it's ab. Then this is b times b, that's b squared. So you end up with a squared plus 2ab plus b squared plus 2. A lot of people forget about that middle term and think that they can somehow distribute the square and get a squared plus b squared. It doesn't work that way. You have to make sure you multiply it all the way out. Now the distributive property, 3a squared plus 6ab plus 3b squared plus 2. And it may be ugly, but that's it. That's our final answer there. Next one, f of x plus h. Notice that the plus h is outside. So that means to take our original f of x